So my name is Ana Batallé, and I'm from Eurecat, which is a technology center in the area of Barcelona. We are currently participating in a project that's called StepUp. And mainly what I'm going to present today is the plug-and-play market solutions for renovation that we are developing within the project. Can you move to the next? So the presentation has 5 points. So first I'm going to introduce briefly the project. Then I'm going to talk about the plug-and-play technologies that we are developing, and StepUp and what we understand for StepUp principles. Then I'm going to move forward to the protocol specifications, and finally I'm going to introduce the technology provider cluster. So StepUp is a project that it's aiming to transform the renovation market, and we are aiming to do that by creating a more attractive and reliable renovation process that reduces the performance gap and that optimizes the investments. Also, one of our goals is to minimize time on site in order to support the reduction in the cost. And this fact, we are aiming to accelerate. With these facts, we're aiming to accelerate the renovation market. So the main solutions that we are developing are 4: the plug-and-play envelope, the plug-and-play smart heat solution. We are also working in developing financial and software tools, but mainly the technologies or the solutions that I'm gonna explain today are the first two, which are if you move to the next slide, which are the plug-and-play envelope system and the plug-and-play smart heat solution. So the main objective of these two technologies that we are developing, for one part, we have the plug-and-play envelope that it's aiming to reduce the energy demand of the buildings. And then we have the smart heat solution that what it's trying to do to support the active system to reduce the energy demand. This is an image of the plug-and-play envelope. So what we can see, it's a prefabricated facade module and this is a mock-up that we are doing currently to test our technology. The idea is that, I'm going to explain this further later on the presentation, but the idea that where we can see here is that for one part we have the technology itself, and there's these black gaps where we are aiming to integrate all the installations and for the active system that need to be provided for the renovation project. So smart heat, it's a heat storage battery. What it does, it stores energy during the day when we can produce energy on site. And then it releases this energy when the demand on the energy consumption increases and there's no on-site production. So in the following slide, we can visualize a little bit what this storage looks like and how the PCMs are integrated within this storage. So one of our goals is to provide a fully renovation package. So in order to complement our main technologies, we need to collaborate with third-party technologies. And for the passive technologies, this would mean like having like the external layer components, the windows and the solar protections provided by third parties, as well as the PV and ST panels, the heating and cooling systems, and the demand control ventilation. So what are StepUp principles? One of the things that we want to do is kind of so these principles need to work as a kind of guideline for the different technologies that are involved in the project for us, but also for these third-party technologies that are going to be involved in the project. And so...
Sorry.
Okay, no worries.
Sorry, I don't know what had happened. It's my fault. You reloaded.
Yeah. In the principles.
Yes, here. Sorry for that.
Yeah. So, well, as I was saying, like we've defined like certain principles that we believed it's important that our technology, but also the technologies of these other companies that are participating in the project need to comply with in order to be able not to match the goals that we are trying to achieve with our project. So I'm going to briefly explain now the different principles so you can have an idea of what we are aiming for in StepUp. So the first principles would be that we want an industrialized solution. This means that the solutions need to be pre-assembled off-site in order to minimize the time on site, but also to reduce the errors, and for like having the opportunity of having these pre-assembled components will also like reduce the impact or the disruption that we are causing in the uses of the building. So that's what it's also important that we can prefabricate and have the solutions kitted before bringing them on site. The solution also needs to be customized. It means that it needs to be able to adapt to different architectural geometries, so to different configurations of buildings, but also to different aesthetics. So we don't have like a standard, solution for renovation solutions, but that we can adapt and we can play a little bit also with the aesthetics of the building and how it looks like in terms of materiality, finishes, etc. Next. As I was mentioning before, it also needs to be compatible and interoperable. So the different technologies need to be able to engage between each other without having to apply major changes, to also ease the process of preparing the kits off-site before bringing them on site and reducing the time. We are also considering the impact that our technologies can have to the environment. So we are considering design for disassembly strategies or the impact of the solutions that we are working with have. So it's not only important, the technical development, but also the sustainable benefit that this technology can bring to the market. For open exchange information, so one of the things that we consider are more important for our methodologies to be able to plan the different steps in order to make them efficient. And to achieve that, we need to be able to exchange easy in a, how you say it? So yeah, like there's different, how you say, collaborators during this process. And in order to efficiently exchange our information, we are trying to set up a kind of like a rule on which kind of information needs to be provided, in which format, etc. And finally, all the technologies that we are developing need to meet with EU regulations, but also in order to be able to understand the environmental impact, etc. We also are asking for environmental certificates. So with these 6 principles, we have like a little bit of an idea of what the project is aiming to, and what these principles are doing. It's kind of relating them with requirements that the whole system, but like also individually the components need to meet in order not to fulfill this new methodology and new technology and solutions that we are trying to develop for the renovation market. So the specifications that I mentioned are currently being tested in a second mock-up in Spain, in Isopani Ibérica. These are some images from the first phase of the mock-up. So what we are trying to understand from here, it's not the different requirements and and like the overall solution, how it works, the time that it takes to assemble it, etc. But also we are using it to verify all these requirements that we are asking to our technology, but also to the third-party technologies to understand if we are asking for something that the market can meet. So we are welcoming currently companies that wants to test their technologies or that want to upgrade them so that they can be industrialized to contact us so we can work together in the development of this passive system and active system. And I think I need to speed up. Yeah.
Yeah, you have 1 minute. You tell me if I have to go to
just
slide.
move. Yeah, I think like this is a collaboration. If you move to next slide.
It's better to, maybe do you want to?
Yeah, well, this is what I've just said. So you can just move to almost the last one. So it was mainly, like saying that we are trying to engage with this third-party cluster of companies, and that what we are asking it's some kind of feedback on the process that we are developing, and what we are offering them it's to have exposure, networking, visibility, to be able to test these technologies, and also like build a network for themselves of different innovation companies that are trying to change the renovation market. And yeah, finally, in the last page, if you want more information, all the presentation, it's collected in a booklet that it's in the definition of the presentation, but you can also find it in our webpage, and you have there our contacts, etc. if you want to know more about it.
Okay, thanks. Maybe is there any question for the StepUp project? Sorry, I'm looking at the refresh your screen to see your paper. Okay. It was an answer to the Leandro Madrazo. So if there is no question, I propose to go to the next one in order to be able to remain in time. From my schedule, actually, the next speaker should be Diego Sansalmela. Is this correct? Okay.
Yes. Could you hear me properly?
Yes. So I share your this slide, because if I understood correctly, you can't do it. Is it right?
Yeah, it's fine.
Yeah. Okay. I'm sorry that I can't help further in on this. I will try to do my best. Okay, so welcome.
Okay, so good afternoon. My name is Diego Sanz, research architect and member of the Valencia Institute of Building. This presentation, as you can see here, for the session is entitled Decision-Making Tool to Support Renovation of Buildings with Industrialized All-in-One Technology Solutions. In the next slide, you can see that this tool, the previous one, this tool is part of the Infinite project, okay, included in the European program 2020. So to put it into context, okay, we will briefly look at the project's objective. You have here the list of the 3 main objectives. So Infinite aims to increase, on the one hand, the market penetration of these industrialized integral building envelope kits for the deep renovation, by developing a set of multi-user and multidisciplinary tools, that the one that we're going to see is one of them, while maintaining the focus on end users, especially for this tool. Okay, next one, please. Infinite is just one example, but we consider it representative as it covers most of the possibilities of today's prefabrication systems. as can be seen here, the kits and technologies that will be developed on Infinite projects are these ones: the green envelope, facade and roof. You have the energy and fresh air distribution, the smart windows kits, photovoltaic panels, thermal panels as well. Then the building management system to meet everything, and then a big platform to meet all the users. Okay, it's important to point out, that the base panel is a basic module, and depending on the needs of each building and the feasibility, the different kits are added to it. Okay, so maybe some of the kits or some of the building will be able to have to use 1, 2, 3, none of them, or all of them. Okay, so how does the need for this tool arise, and what's the starting point for it? Okay, the starting point is the need that appears from the lack of knowledge of the application of these prefabricated products or kits on the part of potential clients or even technical staff sometimes. Okay, the key question is whether I can install such a system in my building or in the dwelling, and the next question is how much would it cost. And the tool would be included in the first of the questions, as it tries to provide the guidance to advise on the suitability of installing one system or the other, okay? And to leave the contact details in case you want to know the cost. Okay, and the next one. Okay, to try to obtain the parameters, okay, the Delphi method was chosen, which is a process in which a series of experts converge to reach a consensus on a common theme or problem. Okay, once the objective was clear and the experts were selected, which in this case were mainly different technical profiles within the technical partners of the project, for example, technicians or research staff, managers, okay? Once we had all of them, then the process followed was this. A first round is carried out in which each expert points out the limiting parameters for his or her kit. After that, the results are pulled so that everyone is aware of them. And finally, a second round is proposed where parameters are allowed to be changed or you can add new ones based on the previous answers. Okay, in the next one, you have the result after this second round. I don't know if you can see it properly, but it is already clear that the parameters are many and varied, and there is no homogeneity among all of them. We can see that there are parameters related to the existence of or not, for example, of balconies, as well as others related to installation, the HVAC system, or even the seismic legislation. So we can see this wide variability. For this reason, and finally, individual technical questionnaires were issued to each technical partner, in which, based on the results of the previous Delphi method, a series of questions were drawn up to filter or really narrow down, okay, which were the most limiting parameters for each kit, for each partner. Okay, the answers to these one-to-one questionnaires were the basis for the questions included finally in the decision-making tool. Here's an example, okay, of some questions trying to find out, for example, well, the previous one, just 1 second. You can see, from the design and installation point of view, if there is a minimum facade size to make the kit viable, for example. Okay, now the next one. Okay, the tool relies on certain limiting parameters to discard some of the kits. For instance, in the case that you can see here, where the sun does not shine directly on the facade, then there will be 3 of the kits that cannot be used, as they need the direct sunlight to work. But so if we answer no, they will automatically no longer be an option. On the other hand, if the answer is yes, all the kits will continue to be viable, and so on until the end of the questionnaire. Okay, in the next one, you can see a schematic example of the implementation of the tool. Sorry for that, but the digitalization of the tool is still in progress. So this is not yet the final image, just a rough idea of how it works. As can be seen, the idea is that based on a set of dynamic questions, okay, which are answered in the decreasing order, we get as a result the kit or kits whose installation is viable in that specific case. Okay, depending on the answers, some questions or others are shown, because it's not the same if you are the proprietary of just one building, the whole building, or just one of the dwellings. Okay, depending on that, you will see a different set of questions. In the example, we see how by answering just 9 simple questions, we try to make the language clear and easy for the end users. Okay, so 4 of the 7 project kits here appear as viable in this case. Okay, in the next one, as a real applied example of the tool, we have the case of the region of Valencia. Okay, here where we have our main facilities, where within the mechanism of the known one-stop shop, okay, which has been very effective worldwide to achieve energy renovation, in combination with others, this tool is proposed to help in the decision-making process of energy renovation in general, to have advantages and disadvantages of all the available products that you have, the wide range. Okay, so the next one. To achieve this, okay, although we focus on demand, on the end users, there is a lot of prior work done, analyzing the different types of building databases, different points of view, and so on, and trying to see what the current offer is within the building sector nowadays. It's necessary to identify where the demand is to target the relevant actions to those areas or markets that we think that they are like key. This, for example, could be achieved through the creation of a GIS map, crossing demand and offer, but there are other possible lines of research to be developed from here in relation to the data obtained, like the definition, for example, of archetypes for the energy modeling that maybe it's more common in other previous European projects, or even the improvement of the existing national and European building related databases. Okay, we can add more parameters to them. Okay, and the next one. Okay, so this is the final part of the presentation. As you have seen, this tool is just one of many that are part of the development of Infinite Project. This one is aimed just to end users and in some parts to the designers, but there will be more focused on the installers, operation, maintenance, and so on. Okay, I encourage you to follow closely the progress of the project and all the related work done so far. So you have below the website. And with that, I mean, we've finished. Thank you very much. If you have any doubt.
Well, we still have some maybe some minutes for question if you wish. What are the next steps for this project? Are you waiting for other answer from the survey to integrate in your model, or which are the next steps?
Now we have like different approaches. This is the approach for the technical. I mean, this is for the end users, but having the information from the technical partners. Then we have like the national approach from the designers, architects point of view, and from the people that now are living on the pilots, because we have like the virtual pilots and the real pilots. So we are working with all this information now, and with the developing of all the systems. With all these parameters, all the technical providers are trying to make feasible all the kits and improve them and developing, because they are starting with some of the kits maybe are more common or are more used, like maybe the green envelope, but all of them are trying to make some better points, like maybe, I don't know, the different colors of solar panels that normally they are just dark, and all these kind of improvements.
Okay, interesting. Thanks. Okay, so here it's the contact. If there are no questions, I propose to go to the third one. I think it's Sebastian Botzler from the Technical University of Munich, if I'm correct.
Yeah,
okay.
I think so, if you have the right presentation.
Yeah. I'm becoming an expert, so okay.
Perfect. No, I thought it's my fault, maybe because I had so many presentations today.
Okay, thank you. If you want to start, it's
Yeah.
fine.
Okay, hello everybody, and thank you for your attention this late timing. This presentation will be a little bit more theoretical as the previous ones. And I have the honor to introduce to you our Research Horizon 2020 research project results or idea of the research project Eurodata. My name is Sebastian Botzler. I'm the coordinator of this project, and I'm currently working at Technical University Munich. Yeah, next slide, please. Just briefly, the project parameters. The project was started in 2019, and we had always a very strong focus on the practical implementation in mind. So this is why we have 3 practical partners: the region of Andalusia, represented by the Andalusian Energy Agency, and the Colegio of Arquitectos in Malaga. Then we have the city of Copenhagen and the city of Velenje in Slovenia. And additional to that, we are presented in 6 countries with 9 partners. There's research partners like the Danish Technical University, the ITTI, or programmers, and data scientists from London Trilateral Research, and us in Germany. So next one, please. But what is Eurodata about? I told you about the participating partners, but the outputs of Eurodata actually, we want to help municipalities and local governments like regions to assess their building stock, not only on the energy side, not only providing an energy audit, but with our tool, our software solution that we're preparing, we want to help them to collect the right data to perform socioeconomic assessment and life cycle assessment on their buildings, which is quite a new topic. And this is why we kept it quite superficial, but we want to give an insight on the potential of socioeconomic effects of building renovation. The outputs are 5 calculation methods, and I will talk about them a little bit later, that are providing the results. Then a parameter and indicator list, especially for the socioeconomic and LCA assessment, because I think for the most municipalities, it's not really clear what kind of data they need to collect to have these assessments provided or conducted. And we have a decision support software, as I mentioned, which is on a web-based, browser-based software tool, which is combining all these methodologies, and the municipalities should be able to upload their building stock data, and then they perform assessments in this online software. This software is currently under development. It's mostly finished. I think we can show them in a later stage, but today I just wanted to get into the idea of the project and the theory behind. Then we have a comprehensive database, which is we have 600 parameters in the project, for which we created proxy values, so that municipalities that don't have the access to the proper data, that they can rely on the proxy values for their region, for example. And the last output is the implementing guidelines. Well, as I said, I wanted to start a little bit from the zoom out from the technical aspects and just mention why are municipalities our focus. And we realized very early in the last projects that we did that municipalities can be a huge role model when it's about increasing the renovation rate of buildings. I think this is something that also the European Commission sees, and they want to push the public investment in renovation rates in general and increase the renovation rate. Why is it so special? Municipalities have actually the opportunity to pilot innovative approaches, technologies, They are the authority over a big building stock, and they have also the authority over public procurement processes, and they can communicate to their citizens. So if they have a lighthouse project, that's a much bigger impact than having a private company there. Then also the municipalities are the closest level of government to the people. We all are confronted with municipality work, even if it's the street, the trash, whatever. There's a direct contact, and the municipalities are politically obliged to invest in European in energy efficiency. And this is something we want to use. The problem is that in the current state, they don't invest enough in energy efficiency. And the consumers, managers, and of energy networks, of course, they are also part of this connection. I will give you a short example about what we wanted to do, maybe. Think about in my hometown, very small village in Bavaria, in southern Germany. You have a kindergarten. In this kindergarten, and the municipality decided to renovate this kindergarten. They had two options. They could go for the very deep energy efficient renovation with a ventilation system, with improved indoor climate, and the kind of cosmetic renovation, which is focusing on energy efficiency. And they, of course, decided for this cheaper version because their budget is not really high. But they didn't have the information of what it actually provides to them, what benefits they can generate when they have a better indoor climate for children. And this is what we want to change here. Yeah, the next one. Wider benefits assessment as a driver. I will go briefly through it because we already have 10 minutes and I'm talking already long. Yeah. So the wider benefits, we call it wider benefits. There's other terms like multiple benefits or the non-energy related benefits of building renovation. And we just determined kind of aspects in which the wider benefits can be a driver. City governments must develop the right policy framework for the implementation. They need to develop long renovation strategies. And for that, they need to provide the right justification and arguments, and also the monetary outputs. And this is why wider benefits are so important, because we want to monetize all these outputs. The local budget must be reallocated towards energy efficiency projects, which means the local budgets need to be balanced differently. They should invest the money into renovation projects, of course, but then they need to also calculate the payback through other means like tax returns or the increase of productivity of the workers. Next one. So I didn't see I know, okay. A little bit delayed. The municipalities must increase the capacity, awareness, and knowledge of energy efficiency opportunities. So what we want to try is, with the wider benefit assessment, we want to put a knowledge about these extra effects into the minds and into the planning and processes of municipalities. And this is why we chose this way of a simple assessment to raise the awareness about what is out there, what impacts energy efficiency and renovation has on buildings and on the municipality and on the occupants of the buildings. And of course, the municipalities must be aware of the opportunity energy efficiency represents. And I think it's a huge opportunity. And I think our first results show this as well. Mm-hmm. Thank you. Next one. The challenges, and then we are over with the very text-based slides. The challenges are that we don't have data for anything. It's really hard to collect the right data. The existing data is uncertain. It's barely available on local level. It's very specific. For example, it's what medical treatment. It's not data that a normal municipality or city has available. It's scattered different department sources, and the lack of experience in these fields in planning and decision making is huge. And also the best practice examples are quite low. I know maybe 5-6 projects which are taking into account all these complex assessments. And then there's no holistic software available yet, and no guidelines how to properly assess these wider benefits. Next one, please. Yeah, and this brings me to our support tool. I want to give you an insight on how it's working and what are the results. So what we're doing with this, it's like I said, it's a browser-based tool, but it's relating to the privacy issues we have with the building data, we installed it in each municipality separately. It's not an online-based, but a browser-based tool, so that the users don't have to install a software or need to get deeper into their into their own software solutions. They can kind of have it as a mock-up over what they use already. We want to integrate it into workflows, into the existing data streams, and of course, we want to apply to the existing policies. So what are the renovation goals? What are the minimum requirements in each country, in each municipality? And we want to take data protection seriously. Yeah. Next one. What we are collecting is the real data, like I mentioned. It's the geometry, it's coordinates, building materials, fuel sources, heating systems, ventilation systems, all these parameters. And of course, we created default data, which is our own database, which contain the same values, but not as precise and not as tailored to the one building that we want to assess. So the more we go away from the real data, the more unprecise the results get. But we defined like 15 or 16 minimum required parameters with which the tools works, the software solution works. We can calculate all the outputs with these 16 parameters, and this is feasible for the most municipalities. And then we have a data part, which is kind of the desired data, we call it, which improves the results incredibly and significantly. Next one, please. Yeah, what do we assess? We assess the energy demand and consumption calculation. This is based on the cubature of the building, on the location, on the heating system, on the cooling system. We assess the life cycle of the building, so embedded energy in the materials over the life cycle, also the building technology life cycles, and what happens when we exchange it. We assess the indoor climate assessment, which is now working for schools only at the moment, in which we simulate the impacts of building renovation on the indoor climate, and we monetize the productivity increase, the sick days of teachers and pupils, all these effects. And then we have the socioeconomic assessment, which is quantifying and monetizing wider benefits like job creation or tax returns. I will come to that later. And then we have the supply side assessment, which is the counterpart. We want to see what does it bring if we invest in supply, in energy generation instead of energy efficiency. And we want to compare these both results to give an overview of the different benefits. Next one, please. Yeah, the socioeconomic module, this is what I want to talk about a bit more in detail, is basically it's a Bayesian network module, so it's probability based. There is no calculations and simulations happening. It's slowly based on statistics and knowledge, and it's fed from the other calculation methods, the energy demand, consumption, life cycle assessment, and indoor climate module, and it kind of processes the outputs of the other modules and provides inputs, results to job creation, impact on the GDP, for example, or CO2 emission targets. Next one. So what is modeled in detail? We have the energy cost estimation. This is, I think, the most straightforward. So we see how much cost we save. And this is what is done already in the municipalities, but we want to have the holistic point of view. This is why we model this as well. Then the particulate matter emissions, how much PM10 emissions are reduced by the selected renovation measures. Then the CO2 cost assessment. Here we're going a little bit broader and saying, okay, we assess the CO2 tax costs, which are available in most countries at the moment, then the emission trading costs, and we added the social CO2 costs with a very conservative number between 150 and 500 euros per ton. And this is varying between the places where we do perform the assessment, of course. Then we have job creation through energy efficiency investments. So how many jobs in the region can be created by the investment? And then the tax returns. So how much taxes are actually returning to the municipality when they make the investment by themselves. This is something that is not really investigated yet. It's not a huge stake, but for some small municipalities, it can be a very interesting opportunity. And then we assess the risk of fuel poverty through household energy costs. So how much in residential buildings, how much do we reduce the household energy costs with the renovation? How much affects the poverty potential of the household? It's planned to extend this through productivity modules and also the health effects of mold and indoor climate. So there is some, it's a very modular approach, so we can actually extend it limitedly depending on the data availability. Next one, please. Yeah, and then I want to show you a short case study. We have a building in Batallé in Slovenia. I don't go into detail about this building. It's a school which has 5 stories, and it's quite a huge building. And then the user has the opportunity to choose predefined renovation measures. Here we chose, for example, add insulation to roof, add insulation to exterior walls, exchange windows, add external shading, and add air conditioning to the building. Especially here, the building itself from the status quo was not a bad one, but we wanted to improve the indoor climate. So this is kind of the case study to show the effects. In the later version of the tool, the expert can define own renovation measures. So you can basically fix and change all parameters in the tool, all 600. If you're really ambitious, you can change all 600 parameters and adapt it to whatever your need is. And for now, we provide a kind of fixed set of parameters with fixed numbers, and you can choose and you can combine these numbers. Yeah, when these renovation measures were applied, we get the results. Next one, please. Which of course shows the energy demand reduction. Here, this is particular because we changed the heating system. But since the building was quite in a good shape in the beginning, the total energy, final energy consumption reduction is quite low. We have 10% of reduction. But the CO2, like the primary energy demand reduction is very high, especially because we have a renovation, we don't have a new construction, so the amount of embedded energy is lower. We didn't exchange a lot of windows, so we have a very low CO2 footprint for this renovation. Mm-hmm. Next one, please.
You have 1 minute.
That's perfect. So next one.
It's this one, the next one.
I don't see it yet. Maybe
the socioeconomic module.
Yeah, sorry.
Yeah,
that's okay. It was a bit delayed here. Sorry. Yeah, and this is the result. So we monetize the effects. You see the total heating cost savings per year for this particular building. Then, of course, the high stake is the total CO2 cost, which is based on related to the social CO2 costs, which are high. And we have the trade tax return, which is 2,000 euros, and the total income tax returns for this project. The overall project costs were estimated around 250,000 euros, so it's not a big project, but you see the results. And then we calculated also the number of jobs and the related unemployment spending per year, which is saved through the jobs that are created. Next one. And I think this is what I wanted to show you. I think it's more clear. What we now did is we created 3 different payback times. One is the payback time without wider benefits, which you see is the lowest line, the highest green, the softest green, and it's calculated about 140 years. This sounds incredible, but of course, since we had a kind of unrealistic case where we applied quite high costing insulation on a quite already good performing building, I think this was the biggest issue. But the focus was to reduce the primary energy consumption. Here you see, if we take into account the CO2 costs, if we take into account the job creation, if we take into account the tax returns, then the payback period reduces around to 14 years. And if we include even societal wider benefits, which we think are for example, the unemployment spendings or health cost spendings, then we can reduce the payback period to 8 years. I think the biggest stake here is the CO2 emission, but it depends, of course, and varies a lot between each case study. And we hope that we produce a publication soon in which we show the different aspects and the different scalability of the tool into different variations. Mm-hmm. That's from my side.
Okay.
Thank you very much for your attention. And I'm happy to answer your questions if we have time.
We don't have time. I was only curious to know how many municipalities did you involve in your project?
We have 2 big ones. It's the city of Copenhagen and there's the city of Batallé in Slovenia. And we have the region of Andalusia, which of course implies all the municipalities in Andalusia. So we have quite a lot.
Okay. Thank you.
Thank you very much.
Unfortunately, we don't have a lot of time. It's a pity.
It's okay. Write me an email, and I'm happy to answer. And also in the chat, I'm happy to answer the questions.
Thank you. So the next speaker is Graziano Salvalai, if I'm correct.
Yeah. Hi, Carola. Hello, everyone. So thank you for sharing.
Yeah, of course.
Fine.
You can start. Thank you.
So good evening, everybody. I'm Cristiano Salvalai. I'm associate professor at Politecnico di Milano. I think everybody know the university probably. It's a technical university that is mainly based in Milan. So I'm going to present the long-term monitoring strategies for increasing energy performance certificate reliability. So this is the title of the presentation. So go the next, please. Thank you. So yeah, I'm starting from the beginning of the energy performance certificate history. So they have a long story. They has been introduced in 2002 with the first energy performance of building directive, and since that time they show a limited impact on the building sector due to several reasons. Here are listed some of them, like reliability, the compliance, and of course, related probably to the low reliability of the energy performance certificate, there is a low market penetration and a very low acceptance by the user. So this is the main reason why the actual energy performance certificates are not, they have not high impact on the building sector. Next, please. The energy performance certificate need to be, of course, improved in terms of quality, overall quality, and we are talking about different layers of innovation. So the first one is introduce or supporting the energy performance sector for a robust, modern, and user-friendly data collection. So data collection is a very important topic in energy performance, structuring and calculation. Of course, the evaluation, the calculation, process is very, very important. And this is linked to the reliability of the energy performance. So very often the calculated energy performance is not the actual one. So this is a very high gap that is need to be solved. And then the last improvement is related to the output, so the recommendation of the energy performance certificate. Since the introduction, the energy performance certificate want to introduce action for the building renovation, so guide the designer and also the owner in increasing the performance of the building itself. And the recommendations are now very, are not so direct, and there are no instruction on how, how introduce the different renovation steps that are normally needed. So the next, please. So I'm talking about a new energy performance certificate. So what I'm talking about is part of an energy performance certificate Recast Project that is a European funded project that has been founded under the topic Next Generation of Energy Performance Assessment and Certification. Next, please. The consortium is represented by 11 partners, representing 7 countries, and the structure is made by research center, university, of course, and also energy producer and provider. That is, in my opinion, very important to develop a robust structure for a new generation of energy performance certificate. Next, please. So here, very short, discussion about the structure of the project. I would like to show it just to say that I'm presenting part of the demonstration and impact evaluation. So the project is very, the structure of the project is very, easy to understand. You can see here we have 3 main work packages. So the one is for the method, the 2 is for the technical development, and the 3rd is for demonstration. So I'm talking about how we can demonstrate that the energy performance certificate Recast is, high quality energy performance stamp for the building. Next. So the objective of our, work packages, and also the objective of the presentation, is how to define and texting the strategies for the demonstration, define the KPI for evaluating the demonstration, and develop required training material for the energy performance certificate assessor. This is very important because if we change rules, or if you want to increase the quality, we need, of course, to train the assessor, and then test the next generation energy performance certificate in pilot. So the demonstration is also always a very important action. We are introducing or demonstrating the next generation EPC in 6 European countries that are part of the consortium. So next, please. So the idea is to validate the results and compare the actual, energy performance with the calculated one using the long-term monitoring. If you go to the next, long-term monitoring is, what is probably important to use in this case, because it's a way to assess metrics that are influenced by the variation in weather and occupant behavior, and also from other operating conditions. So instead of spot measurement and short-time measurement, the long-time measurement is a way for having the big picture of the overall energy consumption and see how different factors can affect the real energy consumption in buildings. The next, please. So regarding the main step of we call monitoring and verification process, we are in the installation phase at the moment. So we plan the monitoring, we select the different demo buildings, and then we are going to send the installation and the different sensors to the pilot country and start the final installation. Then we will collect data for have this comparability of the actual and the monitoring energy performance. The next one. So the planning is very, very important. According to what is required in the different member states for a compliant energy performance certificate, we need to collect the data to be, or better, what we need to monitor to verify the actual energy performance. So heating, cooling, domestic hot water, and electricity are the main energy vectors to be analyzed. And of course, we have different systems to take into account, since we are working in different countries with different technology, with different type of building. We need to plan as much as possible the different scenarios. So if you go to the next slide, the idea is to work with different level of monitoring. We have building across Europe that has been built 50 years ago. Some of them are pretty new, and we have different technology installed on that. Some building has like analogic energy meters. Some of them have as a digital. So the idea is to work with basic level when we have thermal and electrical energy that can be derived only by utility bills. We can have a medium level of monitoring when we can mix between metering and utility bills, and then we have to go to advanced level in case we have like multifamily building with centralized system and so on. If you go to the next, we try to represent and clusterize the 6 different building configurations that are basically representing probably the 95% of building across Europe. So we have the configuration 1, for instance, is like everything is, with single counter. So it's like a single family house where we have bills for electrical energy, for gas, for everything, all the energy vector basically we have in the house. And then if you go to the next, we have other configuration where the icons outside the building means centralized system. So when we have a centralized system, we need to submetering the energy vector in order to bring the specific energy consumption for the different building or in basically apartment. So if you go to the next, there is a graphical representation of what I'm talking about. So if we have a very old building, probably a basic configuration can be applied. If we have a pretty, new building or single family house with a smart energy meter, we can use a sensor for getting, a precise energy consumption over the time. And if we have a multifamily building with a centralized system, probably we need to work with more detailed system, more expensive, of course, and we call advanced energy monitoring. The next, please. Yeah, when we talk about energy consumptions and energy performance certificate verification, the idea is to, in our mind, is to check the primary energy consumption at the end. So primary energy consumption is a way for ranking the quality of the buildings all over Europe, basically. According to the level of monitoring, we need to be careful in translating what we are measuring to what we want to have as final output. This picture is representing with the icons, the color icons, the point where we can measure the energy consumption. That is basically the final energy for our building. Of course, we need to move to the primary energy consumption using the primary energy factor. So this is a way for having at the end the primary energy and the CO2 emission that can be compared with what is written in the energy performance certificate produced by the assessor. The next one.
You have 1 minute.
Yeah, sorry. If we go here to the, this is an example of the, advanced energy monitoring. So we need to be careful here in using the plant system efficiency, since we are submetting the energy consumption before entering in the house. So here it's a bit complicated calculation, but of course at the end the primary energy and the CO2 emission is important and can be derived from here. Next one. Yeah, we are collecting the 6 pilots. So if you go to the next, there is a representation of the Italian one. So it's a multifamily building built in 2012. So the idea is to collect pilots that represent all the typology of building and the technology of building across Europe. So this is the first one. If you go to the next, there are some pictures very quickly to see how is the building. It's very small in this case. We are going to install the system, and the system are in this case centralized for heating and cooling and domestic water. So the submetering here is important. The electricity is collected by a smart electrical meter. The next one. So we are going to also select the proper, this is the configuration, and you can go to the next, we already see it. We are collecting also a sensor kit. The idea here is not to develop a new technical solution for monitoring, is to use a commercial one, a plug-and-play system to be delivered in the different countries, and then set up a robust and reliable system for collecting the data. If you go to the next, very important, and to the final one, of course, the very important here is to collect the an architecture for have access to the data and use then the data for the post-process and comparing it with what energy assessor or the assessor is doing for during the energy performance certification production. So if you go to the next here, you can see the architecture. So the idea is to have everything plug and play with low effort for the user, with low impact for the user, and everything can be centralized. And then what we are developing, the other WP, can be compared with the data we are collecting here. So thank you for your attention. If you have any question, I'm here for give you some clarification. Thank you.
Thank you very much. Unfortunately, here now we don't have the time for the question, but here is the contact, so
yeah,
you can receive a question maybe afterwards this session. Okay.
Of course. Thank you.
Thank you. The next speaker is Giulia Barbano, if I'm correct.
Yes.
Okay.
Good afternoon. Good evening, everyone.
Good evening. Yeah, it's the right welcome. Okay. Ren.
Yes. Thank you, Carla. I'll try to be very fast with this. Do my best. So the presentation was quite long, you see, but we'll try to go through fast. So this presentation is in the scope of the BIM for Rent project. So the BIM for Rent project, just to give you a very high overview, is a project about making BIM tools and workflows easy to use in the scope of collaborative energy efficient renovation of residential buildings. I think this is the most important thing to keep in mind as we go on. So you can continue with the slides. Really we're looking at that sector of SMEs, of that sector of the working population that is not, that does not have a good access to the digital transformation. So if you go to the next slide, one of the idea here is, yes, the core idea then is to make the BIM revolution, the idea of having building information drive renovation, and this has to be available somehow throughout the construction value chain. If you go to the next slide, then core of the project is having workflows that are driven by digital solutions, and we have tools in a digital environment to backbone those workflows. They integrate them in a platform and pilot them. So this is the innovation context for the BIM for Rent project. Then the first question when we're looking at the concept of what the project focuses on is the data, first of all, and that's the first step. But if you go to the next slide, please, and how to manage this data, what then we're going to focus on specifically in this presentation is the next one, is the data-driven design. So exploiting that data, so assume there's been a bit of data collection, there's been some simplified potentially ways of creating BIM models or geometries and information that is relevant for energy renovation. Then how can we support a data-driven design of renovation? And this is what I'm going to talk about briefly today. If you go on the next slide, yes. So we're going to look at a few, not all of them, but a few representative examples of tools for data-driven renovation design that we are piloting in the project. And so keep in mind, we're talking about quite research experimental tools. So it would be a bit of a broad panel on very different stages from the diagnosis to the design. The idea here is that we wanted to guide the design, so throughout, so from the early concept all the way to detailed, and we want to consider multiple aspects of sustainability and allow to deal with different levels of complexity. So this is the high level objective that we had within this activity of the BIM for Rent project. So go to the next slide, please. I'll show you, like, this is the slice of the stack that I will be quickly presenting today. 3 tools for scenario evaluation developed. So the 3B tool developed by Technalia, the Renovation Manager by Novatec in F4, and the scenario comparison tool developed by ourselves at IES. Then we have one of the multiple tools that we have on focus analysis, the BIM Solar tool developed by Enerbim, and then 3 tools for occupant feedback. The feedback tool by TNO, React by Vilnius University, Technical University, and SMAC by EDF, Electricité de France. So, and the first one, the 3B tool is a benchmark and best practice tool. It's intended to show indicative primary energy use of target buildings. So here the idea is to get a sense of which renovation packages would be advisable for that building before even starting to work on the building. So this is based on pre-simulated models. It's a general public tool for end users that are not technical, and it's a web tool that covers a range of cases across Europe. Then the next one, the Renovation Manager. This is instead a tool for building managers that are tracking the process of renovation and starting to look within a portfolio at different renovation. What is in interventions? What are the catalogs, and explore the results on those high level catalogs. The next one then, scenario comparison tool. Here we're starting to go more and closer to the buildings. Here we are we're looking at a 3D model of the area. So based on those scenarios identified before, you can run those energy simulations on the buildings themselves and do a before and after comparison. And this is to really start looking at evaluating the cost and the energy performance of different renovations, and make a final decision. Then, as we go on, then we have the BIM Solar tool. This is specific on solar potential. So, and this is, as you know, is a very timely topic right now as we're looking at energy prices soaring. Here, the focus of BIM Solar is to provide feasibility for PV and thermal feasibility on buildings, and having objects that then can be detailed more and more for the specific building. Then the feedback part of the stack, one of the tools is React. So this is a neuro questionnaire, a system on the acceptance of renovation. So to analyze the quality of the building based on how the end users who use a building that has been renovated, how do they feel about the renovation? Then if you go to the next one, it's SMAC. This is an occupant simulation. So this tool is for energy experts. So it's actually meant to support the engagement of the occupants in renovation and the promotion of efficient post-renovation behaviors. So here, at the beginning of the renovation design, it can be used to assess the impact of the user behavior on the efficiency of the project. And then the next one, and the last one of this quick overview today, is the feedback tool developed by TNO. So this is a tool for the occupants on the effect of the behavior. So you can see how there's quite a strong relationship with UniSmart here, in terms of how different the user can interact with the tool and makes adjustments to the settings of their behavior and see how that changes on the energy used for their house. So for all of these, I just wanted to show you and give you a very quick presentation of all of these. If you go to the next slide, because what I'd like to do is invite you to visit our YouTube channel, the BIM4N YouTube channel. There's a playlist of tool demos, and they're all 5, 6, 7-minute videos, roughly, for all of these, and they will give you a short overview of the functionality and what the user can do. So this is just the invite to visit the website, the YouTube channel, and go and watch the demos, and then you can follow up with us for questions on the tools, and we'd be happy to answer them.
Thank you. Congratulations. It's a very dense project.
It is indeed. So we've used this approach of filming the demos as a way to kind of not overwhelm the audience, but still be able to reach interested people who may want to look at different tools that we're working on.
How many pilots did you use in this project to validate all these tools?
We have 3 pilots, and we're testing a combination of tools on each of them. So it's 1 pilot in Spain, 1 in Italy, and 1 in France.
Okay. Is there any question from the audience? Don't be shy. Thank you. You remain in time. Thank you very much. Maybe in the next slide there is your contact for any question. Okay.
Yeah.
Thank
and we
you
also
very much.
we also have a booth in the conference, so you can come right there. Or contact us from the website, follow us on Twitter, etc.
Okay, thank you very much. So in my list, the next project is presented by Gabriele Fregonese. Gabriele, are you here? I see that you are muted, if I'm not wrong. I see you are mute.
Okay.
It's perfect. No, we can. Yeah, it's correct.
Some setting issue. Okay, thanks. So, hello everybody. I'm Gabriele Fregonese from Sinlock, and I'm here to present you what we are developing in the Invest project. Invest project is financed under the Horizon 2020. It's a project that started in mid 2019 with the objective of defining a de-risking tool for energy efficiency renovation, focusing on commercial office buildings. The project is led by Eurac Research. We have many partners involved, such as Politecnico di Milano and IES, which is just speaking here. And we are developing a tool that may help property owners or financiers of commercial buildings to define and to evaluate the technical and financial risks related to energy efficient renovation of buildings. As an assumption of many of the Horizon 2020 projects financed under this call is that we don't have knowledge about what is the actual riskiness of investing in energy efficiency, since we don't have databases, we don't have historical data, and we can only rely on the design, on on the energy audit, on the energy performance certificate, but we don't actually know how much they are reliable and if the expected energy savings can be actually achieved. So with this project, next slide please, we have tried to define a framework to calculate the actual impact of technical risks into the financial outputs of an investment. So this is the framework of our project. So we're basically developing a web platform that is now under development and will be live in mid-2022, maybe. And it's basically a calculation model that starts from the input from the user. So the user going on the platform will see an interface asking for the data of the building, technical data of the building, and the technical data about the renovation project. So inputting this data, and of course some other financial data about how much is the investment cost and what are your expected financial structure. These data flow into a technical analysis engine that, based on a database and a methodology that we have developed, calculates the riskiness of that investment according to the type of components you're installing, the type of renovation with a very particular detail. And then this technical analysis provides a probability distribution in terms of probability and impact of the risks to occur. And this probability distribution flow into another model, which is called the financial risk evaluation model, that combines all different variables together with the financial variables in order to provide the user with a very important and structured information, that is the probability distribution of the financial results, of the financial outcomes of the investment. So what is innovative in this model is that now when you're planning to do an investment, you can base your evaluation on the design and on what the expected outcome is, so what the expected IRR and the expected NPV or payback time of your investment is. With this model, we are adding a feature, which is what is the probability that your expected IRR of 10% can be actually 8% or 7%. So we are providing you the probability distribution of each of those variables. Then another feature that we're still trying to implement is the multi-benefit analysis. So the same type of analysis, but focusing on the so-called multi-benefits. Indirect benefits, such as increased market value of the building, comfort, health, environment, very hard to assess, but that will flow into the platform. Next slide. Next slide again. Thanks. So starting from the first part, technical risk analysis, together with Eurac and the Politecnico, we have developed a database of technical risks. So splitting the components of the renovation, such as renovation of the envelope of the new windows installation, or on the equipment of the technical equipment, ventilation system, etc. We have defined the probability and impact of the risk to occur. We have defined two main risks. One is what we have called the energy performance gap, meaning what is the probability that after the renovation that the building is not performing as expected, with 4 levels of probability and impact: no, low, medium, and high. And another technical risk is what we have called damage, meaning what is the probability that during the lifetime of your renovation, so what you have installed in your building, you have to expect some extraordinary maintenance or repairing for failure of the equipment installed. So that affects, of course, your financial results. And also in this case, we have identified 4 levels of probability and impact: null, low, medium, and high. Next slide, please. As you can see, we have tried to define, to go in the detail as far as it was possible. So splitting each type of energy conservation measure into components, new windows, wall insulation, etc. And for each one, we have tried to define what is the probability and impact of possible negative outcomes, such as air infiltration on new windows or thermal breach, new builds or wall insulation. And then combining them together through Monte Carlo simulation, we can assess the probability and impact of what we have called the energy performance gap and damage. Of course, according to the input provided by the user and the type of renovation, in particular, if you have certification, there are some correction factors that can lower your risks. So if your renovation project is LEED certificated or Climate House certificated, then you can lower your expected risk. Next slide, please. Then what happens after we have defined the probability distribution of technical risks, so and the expected energy gap and expected energy damage in terms of probability distribution, we put that information into the financial risk model, combining this distribution with other inputs. So basically, the financial inputs, investment cost, and baseline energy price, or even the financial structure. So if you're planning to invest all money or debt, etc., together with other variables that may influence the financial results of the investment, such as the variability of energy price, because if you are expecting energy price to go down, the results may become more negative than expected, and also the variability of heating degree days. So if you are expecting warmer winters, then the renovation becomes less convenient. And combining all these variables together through a Monte Carlo simulation, then we can obtain the probability distribution of the financial outputs, such as the IRR, or the payback time. Next slide, please. Financial risk calculation process is split into 3 phases. A pre-processing, which is the one where we are adjusting the input data. The processing, which is the process where we do the Monte Carlo simulation. And the post-processing is where we take the outputs of the financial of the Monte Carlo simulations, and we do some further analysis in order to obtain our specific KPI, the KPI we are more interested to see. Next one, please. So in the pre-processing, we are converting and preparing the data to be inputted into the simulation. So starting from the distribution of expected damage, which is represented from the technical risk analysis in terms of percentage of investment, and in terms of something per square meter, because it's parametric, then we have to convert it in order to be used together and combined together with other unit of measure. Same thing for the expected energy gap, while we take the historical series for energy prices from external databases, and same thing for the climate factor and the assessment of heating degree days. Next slide. Once we have all data prepared for the processing, then we extract a random variable from each probability distribution to calculate basically our main financial outputs, which is the cash flow, meaning the expected economic savings of the energy savings. So we take a random variable from each probability distribution. We use that random value into this formula, and repeating this process for let's say 100,000 or a million times, then we obtain a series of values that provide us with the probability distribution of the expected cash flow or the expected economic saving. Next slide, please. So after we have the probability distribution of the cash flow, the revenues of the economic saving, we can calculate the probability distribution of the payback time, just dividing that number, the investment cost per that number, or the probability distribution of the project IRR, the NPV, of the equity IRR, or even if we have the financial data, the financial structure of the investment, we can even calculate the probability distribution of the SCR, which is a bankability indicator, which tells you about how much the project is able to pay back a loan. Next slide, please.
Yes, you have 2 minutes.
Yes, almost finished. And then in the post-processing analysis, we can calculate further indicators such as the value risk. This is a more advanced indicator that's more interesting for financial institutions such as banks, that gives you the information of how much you are likely to lose if things go really bad with let's say 95% probability. So in that case, you can say that with 95% probability, you are expecting your IRR to be no lower than 7%, for example. And this is very important for a financier of the project. And this is one of the outcomes that you can find from this platform, this tool. You see in the graph the probability distribution of the project IRR over a different time horizon. Next slide, please. Okay, and finally, you can also use this model to calculate what is the probability distribution of your financial indicators according to different contractual model. So in this case, you can see from the orange curve that your probability distribution, without considering the technical risks, so only considering the climate risk and the energy price risk, is around 13% with very narrow probability distribution. While if you are considering all risks or technical risk, then you are in the blue curve. So your expected value is almost the same, slightly lower, but your probability distribution is much more concentrated on the left tail. So meaning that if you're bearing the technical risk, then you are bearing the risk of your IRR to be on the left side of this curve. While if you're hedging the technical risks, such as by entering an energy performance contract, that you are only bearing the energy price and the climate risks. So overall, your expected mean value may be lower, but you're locking your probability distribution to a much narrower value. That's all. Next slide, please. I think, yes, just the conclusions. We have, in the paper, we have more details about how this works. These models have been tested on a specific case study building located in Rome, but we have also done some simulation on 12 other buildings, and it seems working. We will be hosting a workshop in late October, November, targeting financial institutions to present the details of the model. So if anyone is interested, you can join to provide us feedbacks, because this is still a prototype under implementation by IAS on a web platform. So we are still open at receiving feedbacks from the public, from specifically from financial institutions, with the objective of going live in late 2022.
Very interesting. Thanks. My colleague Regis as a question. Do you consider those multi-benefits in an EPC business model? For instance, Comfort?
Not yet. Actually, there are some models. Some models have been studied also in Horizon 2020 projects, where they are basing the EPC on comfort indicators, on comfort KPIs. Now we are struggling in assessing the probability distribution of multi-benefits, since there is no unique methodology to assess them. We are trying to get through it with the objective of putting something in the platform also about multi-benefits. But it's not easy. It's not easy.
It could be a topic for the next project.
Maybe, but the too little literature and too little case studies.
The colleague Santa has shared a link that it could be interesting on this topic, so maybe you can save it for later. Thank you very much. And Santa, I think you are the next speaker. Is it correct? Hello, we can't hear you. And I can't see. I check if he's still connected. Yes, you are connected, Santa. I just wait for 1 minute if we can solve this small delay. If not, we can maybe invert the order of presentation. Oh, okay. The video is not working. Okay, let's do maybe one thing. Regis, maybe you can contact Santa privately, and we can go on with Pedro Vaz. Are you connected, Pedro? Doesn't seem to be. Is there any speaker of the following session? Georgios Giannakis.
Hi, Karen, I'm here.
Hi. It's good. Maybe we can start from you.
Yes.
Okay.
Sure.
Thank you. I find your presentation. Okay. So you have 15 minutes. Let's go. Thank you.
Good evening, everyone, and thank you, Carola, for being the moderator of this session. I'm Georgios Giannakis, technical project manager in Hypertech Energy Labs, and I'm here today on behalf of the Beamer Consortium as the technical coordinator of the project. So next slide please. Great. So at first, a brief introduction to the Beamer project. Beamer is a project funded by the European Horizon 2020 Research and Innovation Program, focusing on the utilization of BIM to support renovation processes in existing residential buildings. The Beamer Consortium consists of 16 partners from 9 European member states who bring significant expertise and capacity in their respective domains, as well as existing tools that have been adapted, configured, and repurposed for the needs of the project. Partners are spanning from universities and research centers for aspects that require more R&D, to SMEs and large construction companies that are closer to the actual renovation sites. The Beamer solution has already been evaluated and demonstrated into pilot sites, the pre-validation sites of the project, located in Greece, one in Athens and one in Thessaloniki, whose main scope was to provide at the early stages of the project feedback to the development partners of the tools for improvement of their components. And currently we are in the phase of performing the demonstration into actual renovation projects, one in Spain and one in Poland. The Beamer objectives actually are mainly 4, and for each of these objectives there are dedicated tool sets that are working collaboratively to meet the requirements and quantify these objectives. The first objective is automating the creation of BIM model and other digital information, where actually we have digital tools to expedite and streamline the collection of such data. We have the second objective, that is the development delivery of a renovation decision support system, where actually we are running different simulations to evaluate potential renovation scenarios beforehand and without being applied in reality. We have also the third objective, that is about a tool set, the development delivery of a tool set that supports the workers and the residents during the actual renovation works. And last but not least, we have the core of the project, that is the interoperability framework, which is actually the common data environment of the project, where all the tools could upload data and consume data seamlessly. And next slide, please. So, as I mentioned before, for each of these objectives, we have different building blocks and actually tool sets. And moving from the Beamer concept to the Beamer solution, development delivery, you see from the left to the right that each of these building blocks consists of many components that work collaboratively to deliver the scope. Next slide, please. So I hope that, unfortunately, I don't have time to present all these components, but what I tried to do here was to pick some screenshots from the interfaces of all these components and to put them around the conceptual architecture of our solution. Unfortunately, as I said, I cannot present each and every tool in detail, but you could visit our website to see further details for each component. Next slide, please. One more. Sorry for the animations. Okay, great.
I hope it's the good one.
The previous one?
The previous one.
Okay,
yes.
Great.
Okay.
Yes, just to emphasize that this talk is mostly about the first phase of a renovation project, where we are actually collecting information of the building and then perform the renovation simulations to evaluate current renovation measures to be applied in the buildings. So next slide, please. So emphasizing on that part, how we perform the renovation evaluation and the energy performance simulations. Actually, there are very specific requirements to perform some detailed energy performance simulations. And these data requirements fall under 4 main categories. Collection of static data that are about geometry, construction, materials, and HVAC components. Dynamic data that are actually information about how the controllable elements of the buildings operate. Weather data about the climate conditions of the building where it's located. And finally, other simulation parameters, which are actually information about that require domain expertise, information about the specific algorithms, convergence criteria, and so on. So next click, please. Great. The way to collect the weather data and the other simulation parameters is straightforward. But what is the obstacle, let's say, to collect and meet all the web simulation requirements is how do we collect the static data and dynamic data. Actually, the current practice of collecting static data is to collect this information from scratch, and which is a time-consuming process and often require more time than that's available within the project deadlines. And apart from that, this data collection needs also some transformation to be performed to transform this information that has been collected to input data format files that are readable by simulation engines. And with regards to the dynamic data, the limitation that many projects are facing right now is that the way that the dynamic data are incorporated in simulation engines are oversimplified using either deterministic or predefined rule-based schedules, which results to a gap between the measured and simulate energy performance of the buildings. Next slide, please. So the Beamer aims to provide a solution about these limitations, and actually it develops and delivers tools that automate the collection of static data and dynamic data. For the static data, we have developed such components where actually we create automatically the Beamer model, and for the dynamic data, we have developed tools that transform consume information that comes from IoT data, train models, and define new methods and models that can be used to reduce the gap that I was referring to before. Next slide, please. So starting with the static data, the first tool that is applied and has been developed in the context of Beamer is the Scan2Beam, where actually the Scan2Beam is a tool set that requires as input the 3D laser scanning results, interior and exterior of the building, and some photographies. And the output is a building information model that includes information about the geometry and map components. And it includes subcomponents. The first is about the Scan2Beam structural transformation to create the building walls, slabs, and so on, and then geometry. Then we have the Scan2Beam map subcomponent, which actually enhance the previous, the result of the Scan2Beam structural subcomponent with map components information by detecting these components from photographies. Then we have the Scan2Beam editor, which is actually a subcomponent that allows the user to enrich the resulted BIM model with additional information, for example, materials and constructions of the building. And this actually performing all these subcomponents under umbrella component. We have, as a result, the first version of an IFC5. Next slide, please. Which is ready to be processed by other components. And actually, although the IFC, the BIM model is in IFC, IFC is an open BIM standard format file. We need to check if this, the resulted IFC file is complete, consistent, and correct, so as to be straightforwardly used by the renovation decision support system. And to do so, we have the BIM platform, where actually the BIM management platform, where actually it's a web application that allows you to upload the resulted IFC file, perform some checks, and in case that errors are detected, you can visualize them through a 3D viewer that it includes, but also provide a report error file back to the Scan to BIM to perform the modifications. Next slide, please. So we're talking about an iterative process between the Scan to BIM and the BIM management platform. Actually, after having an error-free file, the IFC and the BIM model is ready to be processed by the renovation decision support system. So, so far we have prepared and deal with the static data of the building. Next slide, please. With regards to the dynamic data, actually we have developed another component that is named Props, where actually what this component does is to acquire information from a WSN installation, wireless sensor network installation of the building, IoT data, and perform some machine learning-based algorithms to train some occupant behavior models. The trained occupant behavior models are being used to populate an occupant behavior XML data format file based on a standard that is being called the OBXML. So we have, as the result, occupant behavior models that mimic the specific building and not generic information to capture dynamic data. Next slide, please.
You have to 1 minute.
Yes, I'm pretty close to the end. So we have talked about the static data, the dynamic data, weather data, and the other simulation parameters. So we have all the data that are required to perform some renovation scenarios evaluation. For that purpose, we have developed the renovation decision support system, a web-based system, which actually requires as input the BIM model, but also the OBXML, and then performs some simulations. Actually, to perform the simulations, it automatically generates candidate renovation measures and renovation scenarios, which renovation scenarios are actually combination of renovation measures, and calculate some KPIs, energy KPIs, LCC, LCA KPIs, and urban planning KPIs. All these results can be viewed by the user, and the user can select the renovation scenario that meets his or her requirements. And by selecting this specific renovation scenario, he or she can download the BIM model that includes all the measures that are applied for the renovation of the building, but also you can download a report PDF file including further details about what its renovation scenario includes. If I'm not mistaken, that was the final slide of my presentation.
Thank you, Jorgos. Thank you very much. Is there any question? If not, I propose to go to the next presentation to be sure to remain in time. So I see that Senta is now here. Thank you very much, Jorgos.
Thank you, Pitarala.
Welcome back, Senta.
Thank you. Sorry about earlier.
No problem. You are ready to go.
Okay, perfect. So sorry, I think it seems the title of the presentation has gone missing on this slide. But yeah, I'm going to present you something about the ComAct project and the report we did on the energy poverty concept and its implications for Central and Eastern Europe. And maybe shortly just something about the ComAct project. It's a project that tries to trigger deep renovations for energy poor households in Central and Eastern Europe, plus Ukraine and North Macedonia are two non-EU countries that are part of this project, which is super interesting and sometimes a little difficult when you're looking at EU policies and that have not been implemented in these countries, not yet. Next slide, please. Yeah, so in our energy poverty report, starting with the project, we looked at what energy poverty actually is and how it can be defined and how can we actually, I mean, we were trying to find energy poor households. So it's of course very difficult to see how do we define energy poverty. There are quality and affordability aspects. Especially in Central and Eastern Europe, we have different energy sources available that do not actually show, for example, in the statistics, if somebody's using firewood that they're collecting in the forest, they're obviously energy poor, but they don't show up in any statistics because that's not something we have statistics on. We saw that there are a lot of difficulties of defining what's adequate needs. So how do we actually define if somebody's not heating their apartment enough or is warm enough or comfortable enough? I mean, we heard about a lot about comfort and multiple benefits already. And that's, of course, a huge issue for energy poor people because they often live in buildings that do not provide any comfort, or not much at least. So you can hear a little graph of different aspects that are important for energy poor households. And we also saw that there are different strategies of energy poor households. For example, some underheat their apartment or their building. Some cover their energy costs differently, or they don't eat and therefore they heat, things like that. So it's very difficult to identify them in the statistics, but it's definitely a huge problem, not only in Central and Eastern Europe, but in the whole of Europe. And it's very stigmatized actually, and that's why it's also very difficult to identify and also contact these people, because you don't want to stigmatize them further. So ethical questions of energy poverty are also something that we cover in our project. Next slide, please. Yeah, here we see again, you see the situation in Europe. This is from the Energy Poverty Observatory. And we also see like one major problem that we identified in the European Union and other countries is that there's actually no clear definition of what energy poverty is. So it is difficult to actually target policies at energy poor people because we don't know who they are, and it varies from country to country since there's no European-wide definition. We have in Central and Eastern Europe the situation that underheating is widespread. there are many privately owned, not only houses, but also apartments, much more often than in Western Europe, in the countries. And therefore, people are often left alone with this problem. And we don't have the social subsidies that we often find in Western Europe, in the Central and Eastern European countries, let alone in Ukraine or North Macedonia. So often it has been that there were subsidies on gas prices, for example, or electricity prices, which have continuously also decreased in these countries, making the problem more imminent. Next slide, please. Yes, so on this is the basic situation. Let's say energy poverty was, of course, part of the renovation wave that was published last year, and we looked at that also. And the renovation wave has this energy poverty recommendation as part of it, and that goes into the direction of liberalizing energy market, distributing energy differently, addressing barriers to energy efficiency and in investments, but also making use of funding programs and using also energy services. But the problem remains that it's difficult to define these energy poor people. It's difficult to find them. Plus, of course, if EU funding programs don't target specifically energy poor people, so there needs to be some clear targeting of these populations that live in the worst performing buildings and suffer from energy poverty. Next slide, please. And another part of the renovation wave is the Affordable Housing Initiative, which is to kick off in 2021 and is interesting enough part of DJ Grow. So that says that it wants to ensure affordable living costs for rent, energies, and other charges. There will be 100 lighthouse renovation districts and the inclusion of vulnerable communities and neighborhoods with social problems. So, I mean, we have those in CEE. For example, we have a large Roma population that suffers from energy poverty, stigmatization, worst performing buildings. So we'll see if those are even actually included in this initiative, but it would be interesting to see. It should produce measurable reductions in GHG emissions, which means that it doesn't need to trigger deep renovation or have new buildings that are very energy efficient. And it should be kind of a laboratory to try out new things, new initiatives, new projects. Thank you. And we identified, as I said already, I mean, funding is key for energy poor and worst performing buildings and deep renovation. So we looked at the recovery plans that we had at the moment of publishing the report. That was in April. So we didn't find any money earmarked for energy poverty. And we see that also in the NECPs, for example, countries do not actually address the problem of energy poverty adequately because they don't actually put out any specific programs to target energy poverty. So we would wish that that was the case, and maybe the Affordable Housing Initiative will be a first start. Also, I think the European Bauhaus Initiative could be a start to, or could be a part of including energy poor people. Next slide. Yeah, this again shows, I mean, the differences kind of between Central and Eastern Europe and Western Europe more. I think the main thing is also to say, I mean, when we look at, and that's the next slide also, when we look at different financial instruments that we have, we see often a lot of examples from Western Europe, from Belgium or Germany or France. Ireland is always top of the list, but we don't actually see many examples from Central and Eastern Europe, although they have a completely different background than Western Europe and a much larger problem of energy poverty. So that needs to be put much more into the foreground. We looked at the different instruments that we could identify that were already in place. And we saw that most of them finance structural renovation of the buildings. They try to improve the data with energy audits. A lot of them actually provide financial support for energy bills through the social system. And of course, that's targeting more the the problem, but not in a long sustainable term. And legal disconnection protection is often used, of course, and information and awareness measures, which are very soft measures. Next slide. Yeah, and here you can see an overview, which we did of the schemes that we looked at and the budget. And well, the focus of our project is multifamily apartment buildings. So this is what we did here. We looked at if they target multifamily apartment buildings, MFABs, and we looked at are they accessible to energy poor people, and do they trigger deep renovations, because that's what our project is trying to do, trigger deep renovations for energy poor people. And we saw in this case that these instruments that we analyzed, and that are like flagship initiatives also in Europe, actually none of them target energy poor people and trigger deep renovation. So this is what we're trying to do in the COMACT project. We have we're establishing resource centers, and we've established the first one already in the Ukraine. And these resource centers are supposed to bring the information to energy poor people. They're kind of they could be kind of developed into one-stop shops in the end, I guess. But in the first instant, they are trying to identify energy poor, vulnerable people in the communities, and providing them with information on financing and possibilities of deep renovation of their buildings. Next slide. Yeah, so the issues we identified when we compared these financial instruments was that structural improvement to renovation needs investment from the building owners or an increase in the monthly costs. So either one-time investment or increased monthly costs, which of course they need help with. It needs a broader scope. Energy poor households need to be targeted more broadly, and there should be 100% grant program. So 100% of the cost should be granted, and not only parts, because energy poor households obviously can often not bring up any of the money that they need. And yeah, I mean, what we saw from these instruments that were tailored to energy poor people specifically was that they had very low budget, so that's why they don't trigger deep renovation. They treat mostly the symptoms of the energy poverty, not the energy poverty's cause, which is the badly performing building. And they don't focus mostly on multifamily buildings because, of course, I mean, especially with these owner-occupied buildings that we see often in Central and Eastern Europe, the owner structures are difficult. There are energy poor owners next to not energy poor owners. Everybody has different financial means. Everybody has different interests, and therefore it is very difficult to trigger this. And we are hoping with our resource centers that we can somehow overcome these differences and through information and advice. Next slide.
You have 2 minutes.
Okay, this is my last slide. I just put some questions here actually that for you to think about, and also that we are still thinking about in our project. That is like our worst performing buildings, those that inhabited the lowest income groups. How can they get more financing? Is gentrification one of the problems also that's included, or is it a solution, so to speak? We need to include more voices from Central and Eastern Europe in the European debate. We need to look at more what their needs are also, and not only Western European energy poor. We need more good practice. And multiple benefits should also be included because, well, deep renovation triggers multiple benefits, and they also need to reach the energy poor households. And then minimum energy performance standards, the solution, that's always, I guess, the question nowadays. Thank you. That was, yeah, it.
Thank you.
If you're interested in learning more about the project, then I'd be happy to answer you by email or chat or whatever.
My colleague Regis in the chat pointed out a specific incentive in France. Maybe you can have a look at this link. I imagine that the issues in France, the context can be different than in
no, we actually also looked at France. That's, I mean, we've looked at different initiatives all over Europe.
Okay. Thank you, Santa.
Thank you.
So now I think Pedro is now available. So I take his presentation. Okay, Santa, did you share the French? No, okay, this is the website of the project. Okay, thank you very much. Is Pedro available? I'm not sure to see you in the list of speakers here. Okay, he's in the list of people, but I can't see him here. Maybe I ask my colleague Regis gently to check with him. And I propose to leave the place to Leandro Madrazo. Are you here? Okay. Okay, only 1 second because I downloaded the slide from my email. So just 1 second, please. One second, sorry. We didn't have the last version, so I just have to download it. Oh, okay, my downloading is very slow. I'm sorry, I have some issue with the presentation. Because I imagine this is not the right one, isn't it? Leandro, I'm very sorry, but maybe because of many tools open, my downloading is having some issues. Is this presentation maybe right or no? Sorry. Oh. Leandro, we can't hear you. You are muted. You are muted. We can't hear you. I'm sorry. I'm not you muted. Ah, I saw you muted. I try to act somehow, but don't know. Oh, okay. In the meantime, my PowerPoint reacted, so it's good, at least. But I can't hear you. I don't know why. Yes. Is maybe my problem, or is there any other? Okay, Leandro, you are here.
So, can you hear me now?
Yes, now yes.
Okay,
I
perfect.
succeed also in having your presentation downloaded, so I'm happy.
Okay, great, thank you. So, yeah, thank you, and particularly thank you for those who are here until the last minute. So this is a time pack. This is a coordination and support action that started in July. So we are in the beginning of the project. So my name is Leandro Madrazo. I'm the coordinator of this project. So next slide, please. So this is a consortium composed of 13 partners, as you can see here. So from 7 European countries, and we have certification public bodies, we have local energy agencies and consultancies, we have software developers and research groups, and also a communication agency. So these are, as you can see, a comprehensive consortium covering expertise that we need in order to contribute to the development of EPCs according to the vision I'm going to show now in the next slide. Yes. So this is our vision. This is the way we see the situation now with energy performance and what has to be done. And I guess that many of us agree on this kind of diagnosis that we need to have energy performance certification that is not done only one time, but is done on a continuous basis. We also need EPCs that are not only focusing on the building as an object, but considering the building integrated into a larger environment, which includes other buildings and also includes transport systems and energy networks. And what we need is just to understand the flow of data that these buildings in this comprehensive environment generate in order to improve the certification process throughout the lifetime of the building. So this is how we see right now the situation with EPCs and how we visualize what has to be done in order to enhance the existing EPCs. So the objectives summarized in the next slides of the project are here represented. So what we want to achieve or contribute, because this is, of course, a very comprehensive objective that goes beyond this project, but we want to contribute to move from a single static certification to a more holistic and dynamic one by seeing buildings as part of a built environment, by also seeing the buildings as dynamic entities that are continuously changing over time. And our project focuses mostly on data generated through all the life cycle of the building and also the life cycle of the EPCs. And that I can explain in the next slides. So this diagram explains actually the focus of our project, which is data, the data flow, the EPC data flow, which we identify in these 4 stages, which is the generation, the storage, the analysis, and the exploitation. Our hypothesis is that we need data, and we need better data or enhanced data for each one of these stages. For the generation of the EPC, we need better EPCs with more comprehensive and reliable, particularly reliable data. We also need repositories that are collecting this data. We also need procedures and tools to analyze these repositories of data of EPC. And we need services to exploit this analyzed data. So each one of these stages requires better inputs, better data, but also what is preventing or hindering the continuous data flow are the connections between these stages. So we need to improve the connection between the generation and the storage. We also need to develop more powerful tools to analyze the contents of the EPC repositories. And we need innovative services to exploit and to get benefit from the EPCs, from the enhanced EPCs, to make them a valuable tool for the renovation building renovation, for example. So next one, please. Summarizing these objectives. The next slide, please. So are the specific objectives for the project? No, the previous one. Specific objectives. Yeah. So is to increase the quality and reliability of EPC schemas. We want to also enhance them with SRIs, or Smart Readiness Indicators. We also would like to want to integrate the EPC databases with other data sources, including BIM data. And as a result of all of this process, we expect to provide training materials and new know-how to get advantage of these enhanced EPCs. Next one, please. We have already gathered some experience in this line of work of integrating data from different data sources for EPC certification in previous projects developed by some of the partners, one of them by ourselves, our research group, together with ICAEN, the Catalan Institute of Energy, also a partner in this project. Next one, please. Also, other partners have developed other tools in this direction, like the partners from Joseph Institute, from CIRA, and also from Cyprus. They have worked in this project and fund. And the next one, Polito has worked in previous projects, Taul and Episcope, which are dedicated to the generation of prototypes in order to evaluate building typologies. Next one. So the project concept, we have developed this concept of transversal development scenarios in order to develop these 5 scenarios that we describe here. Integration of BIM with EPC, enhancing EPC schemas with operational data. The number 3, creating building renovation passports with data repositories. Number 4, integration of smart readiness indicators with EPC. And the number 5, large-scale statistical analysis. All of these scenarios integrate actors, data, and processes from the different countries involved. So we wanted to overcome this limitation of pilot and country. And these transversal development scenarios indeed involve all the countries that are participating in the project, because what we want is to reinforce the cooperation and get, as a result of this project, some methods and tools that can be applied not only in these 6 countries, but also in other countries in Europe. And that's the output we want to achieve. For that, for creating these transversal deployment scenarios, we will use the data, distributed data in different repositories available in the different countries. In the next slide, I will explain in more detail what is the transversal deployment scenario and how it is related to other scenarios. So transversal deployment scenarios that I have named, these 5, are connected to the demonstration scenarios who come afterwards, in which we will try to prove that all of these processes that we want to test and develop in the deployment scenarios can be applied in real cases with external actors. And as a result of that, of these 2 scenarios, deployment and demonstration, we will apply this know-how into training scenarios, into academia, Time-Pack Academy. That is the final output of this project. Next slide, please. So the transversal deployment scenarios, the purpose is to deploy and deliver new methods and tools to implement these enhanced EPCs in the 6 countries. The next one, please. And each transversal deployment scenario encompasses various stages from the EPC workflow: generation, storage, analysis, and exploitation, and involves multiple stakeholders. The next one, please. As a result of these deployment scenarios, we'll have outcomes that will be applied in the demonstration scenarios, as I said before, in real settings and for specific target groups. Next one, please. So these are the demonstration scenarios, whose purpose is just to test the new ways of improving EPCs, enhancing EPCs, connecting EPCs to the different stages of the data workflow. Next one, please. The results of the deployment and demonstration scenarios is a know-how, processes, tools, data, methods that are feeding the Time-Pack platform. And this know-how will be here systematized, collected. This is also a product of the project we want to develop. Next one, please. And this Time-Pack online training platform will be offer to external stakeholders. So we expect to have here people coming and registering for following and applying the methods we have previously tested in the demonstration scenarios. And as a final feedback, and the next slide, please, we'll have the training scenarios where we will offer training for these new methods that we have previously developed. So basically, next one is the last slide. So we have planned different networking opportunities and events to share the knowledge and the know-how as the progress evolves, particularly the international workshops that will start in December, with the one in Slovenia that follows the previous time park workshop that we successfully implemented in Barcelona 2 years ago. And then will be followed by another workshop in Italy and a third one in Austria. It will be a final conference in Barcelona, and the nearest event is tomorrow, precisely here in this conference, where we will be participating. One of our partners will be participating in this next generation EPC cluster to which we belong since the beginning of the project. So I think that was the quick overview of the project, and thank you very much for the attention for those who are here.
Thank you, Leandro. Thanks for reminding us about the presentation you will have tomorrow on sustainable places. There is a question from my colleague. Are you looking at improving EPC in residential or non-residential buildings, or both?
In principle, it's both types of buildings that we are considering, yes. Now, precisely, we are doing now a comprehensive survey to see which buildings we have from the different countries, which data and equipment. And based on this analysis, we'll proceed with the construction of the deployment scenarios.
Okay. Thank you. Thank you very much for sharing. I see now that Pedro is connected. So I thank you, Leandro, once again, and I go to the last presentation of today's session, which is about the citadel of Cascais. Thanks, Pedro, for being here. I present for you because I don't know how to give you the control.
Yes. You are going to pass the slides, right?
Yes.
Okay. Thank you very much. So next slide, please. I'm presenting a case, some work I did in 2011. And with the beginning of the context, Portugal is that country on the left. We have 10 million inhabitants, 6 times less than Italy. Wait, next one, please. Next slide, please. Our first, no, okay. We had a kingdom, but we had the republic. Yes, this one. We had the kingdom. Our first queen was an Italian lady, and the daughter of the first king of the United Italy was also our queen of Portugal. So it's a funny thing. Next one, please. We had the Republican Revolution in 1910 and became a republic. Next one, please. But the president uses some of the old palaces. Next one, please. That belong to the royal family. Next one, please.
Lucky him.
Yes, and these palaces are used for state dinners and state events, of course. Next one, please. But for the presidency, there was decided that 2 small, modest palaces would become for the use of the president. Next one, please. One is in Belém. This is the presidential palace. And the other one in Cascais, the one I'm presenting, is something like a summer palace for the president. Next one, please. And in Cascais, because Cascais is something like, next one, please. something like a romantic area facing the sea. Next one, please. And the presidential palace is located inside a fortress. And it's that rose building we are looking with that terrace over the walls. Next one, please. And all the intervention was something like a light cleaning on the inside of all the dust and the small demolitions, and with some new additions in order to have a new program installed. Next one, please. Again, the same, just the additions in red and the things demolished in yellow as usual. Next one, please. These are some of the elevations and sections. Next one, please. And here we can see that the program was structured to be put inside the existing spaces. Next one, please. Trying to find the most suitable function for each place according to the nature of the place. Because of course finding the right use for each of these spaces is something like half of a good project done. Next one, please. And in the end, the result is this one. The building is the yellow one that you see. The small one in white that is facing the sea, and the area of the garden with the swimming pool. So next one, please. We began the intervention, removed all the tiles and put some, it was installed thermic isolation and waterproof protection, and a new bridge was designed to reach the terrace. Next one, please. All the lime plaster volumes and modulations of the facades were redone in lime plaster, of course. Next one, please. And we did we looked for the original color and we found that it was yellow in the beginning, so we came back to the yellow. Next one, please. With some lightening for night and evening events, of course. Next one, please. On above the walls of the fortress, all the stones were removed and some waterproof canvas was installed to prevent the water from coming into. Next one, please. Into these areas that were underneath the walls, and that became something like an exposition area. Next one, please. As we can see here, they were all isolated areas and they were all connected in order to make a exposition area. Next one, please. The big room that was made in 1936 in concrete was removed the floor in order to put the air condition on the ground with the machines underneath. Next one, please. And the wall that was on the edge of the room was opened in order to have the open view to the harbor of Cascais. Next one, please. On the terrace was made an area with a garden and with a house in the garden that was covering the exterior units of the air condition. Next one, please. And is now used as a house that used for lunches around the swimming pool. Next one, please. And well, the one image of the swimming pool, seeing the palace on the left. Next one, please. Some of the corridors were redone of the military structure were redone with a contemporary design because they were lost and they were redone. Next one, please. Some new bathrooms were designed in order to serve the big saloons, the protocol areas. Next one, please. These areas were restored where they needed. There was a restoration work. Next one, please. Something like in this room, it was all in wood, and it was it was restoration work. Next one, please. All the interiors, we looked for the original colors, and we tried to repaint the areas with the original colors. Next one, please. Again, the same, some of the image of the interior on the end of the works. Next one, please. And we had a chapel. There's a chapel next to the palace that was all painted with enamel painting, and the major work was something like the restoration. We had to undo what has been done in the past, removing all the painting and discovering again all the faked stone that was underneath the painting. Next one, please. And so the chapel in the end became with this look. And next one, please. And because there was the altar and the pulpit and all the chalice and the pyxid and the patterns were lost, we designed new ones in order to give mass again. That is already working again. Next one, please. And so the citadel that was lost for 50 years, it was not in use. It's now used again, and so our president, our former president, it's in the middle. It's there in the citadel with King Juan Carlos and the president of Italy, Napolitano, and it's just the funny thing that again presidents and kings are again in the citadel. Thank you very much.
Thank you for sharing this beautiful project. Amazing.
Thank you.
Thank you. I think if there are no questions, I really want to thank you all for being here and for all your presentations. It was very, very interesting and fruitful to exchange our work. And so thank you very much. Have a good evening. And if you are connected tomorrow for other workshops in sustainable places, enjoy it.
Okay.
Thank you.
Bye-bye.
Bye.
Thank you.
Thank you. Bye.
Thank you. Bye-bye.
Thank you. Bye.